This is where we left off. We were talking about science, faith, and reason, and this is our third little session on it. And we've talked about several evidences for the, without scripture, to show that the biblical vision of life is actually comports very well with the scientific understanding. There's four fundamental features of the world that we talk about. The first fundamental feature is the evidence for the universe's beginning. The second fundamental feature is the fine-tuning of the cosmos. The third one is the impossibility of biogenesis, the beginning of life itself. And the fourth one is the nature of information. And so we did the first two. We looked at the evidence for the universe's beginning, and then we explored the nature of the fine-tuning parameters, and they're so exquisite that we kind of developed a number of them, and I just wanted to pick up one thing where we left off here. So, for example, the expansion rate of the universe has to be within one part in 10 to the 55. Any more or any less, we couldn't have this conversation. Things of that nature it's almost impossible to calculate. So the best you can do is to imagine what it would have if you had a pencil that you put on glass and made it stand up by itself. And then the odds of getting that up there aren't great, but then you get 1 million of them, and that's getting closer to it. In other words, it's beyond your comprehension when you're dealing with these numbers. The same was true as well of the stellar mass. Regarding the relative proportions of, for example, the electromagnetic force versus the gravitational force, they had to be within 1 part in 10 to the 40. These are figures that are really go beyond our grasp, our comprehension. So we're looking at all kinds of things: the strong electromagnetic, the expansion rate, the stability of the deuterium, a whole array of these things. And so we're looking at features of the universe that make it just has to be just right galaxy, just right sun, and just right mass. It's a circumstellar habitable zone. It has to be just the right location there. And when you actually do a very conservative estimate of the probability of getting just a modest handful of these parameters, because when Cosmos came out, remember the movie with Contact, Carl Sagan, and the idea is all these billions and billions of galaxies. So clearly there's got to be a complete waste if there was only one place that had life. But what if it took a universe of this nature and of this size, and to actually have the conditions where we could have this one conversation, because it's exquisitely fine-tuned. So even if you postulate a very generous amount of planets, say 10 to the 22 planets, the one chance in 10 to the 215 is based upon a very conservative estimate of about 100, not even 100 of these parameters. They keep growing because it used to be the Drake equation. There were only 20 of them, and they figured they could actually have a possibility where you could have life, and that was when in Sagan's time. But now it's multiplied into not just dozens, but now hundreds and hundreds of these fine-tuning parameters, and they keep growing, and begin to, oh my word, it had to be this, it has to be right there. Even in the right place, it has to be in the galaxy, it has to be the galactic habitable zone, things of that nature that were recently discovered. Only a 4% band within the galaxies, and if you were any closer to the center or the further away, you couldn't have life, and there are many reasons for this. But it's also, we're the privileged planet, as Guillermo Gonzalez put it, because privilege insofar as not only are we this Goldilocks world, but more than that, it's also the idea that we are right in between the interstellar gases that make up much of our galaxy's spiral arms. We're in between that. So we're able to see, we're in the perfect place to look out from where we are and to see what we're seeing. And if we didn't have those conditions, we wouldn't really be able to have this vast grasp, a growing grasp of the greatness of our cosmos. Even as I mentioned before, the perfection of the system whereby we can see a solar eclipse, a total solar eclipse, which reveals a great deal of knowledge about the sun that you could not otherwise have about the corona. And the only way you can have that is for it to be perfectly aligned. And it turns out that the moon is 400 times smaller than the sun, but it's 400 times closer than the sun. So they perfectly overlap, and therefore we get to see. It's just so delicately tuned, and you just go on and on and on. You begin to see it's elegant, it's exquisite, it's rich, and it's comprehensive. And so given that, it really adds to that. And so the desperate measure that some have actually taken was that of a multiverse. So some have now postulated that, well, perhaps, I know we seem to have won the cosmic lottery, but at the same time, maybe there's an infinite number of universes or a boundless number of universes, and we just happen to be one of the ones that hit it. That's taking a great deal of faith, because first of all, you have to deny the first and second laws of thermodynamics to do it. And secondly, you have to buy something that has no empirical warrant whatsoever, because you cannot, in one universe, have empirical evidence for another. So who's living by faith? It's a desperate move, and the real thing that motivates it is to avoid the obvious implications of the anthropic principle, that namely that we were designed for this purpose. So, but I'm not even mentioning the whole idea of scripture at all. I don't even go into that during this talk. So the same is true with another desperate measure we talked about, panspermia, and I think we may talk about that later, where, that comes later, where the probability of life evolving on Earth is so low that now it's said, well, it must have come from outer space. It was basically seeded from outside. What's the problem with that? Well, it's not that hard to figure out that you're only putting off one portion. Where did that come from? It's not really complex. So you're dealing with things that have not been seen before that are quite remarkable, and it's impressive. So when I look at this and I recognize here, we go to the inference to the best explanation, and this is where we left off before. And so when you look at this, natural causes will account for this in South Dakota, where we have Mount Rushmore. But when you're looking at the idea of the Black Hills of South Dakota, most of it you can attribute to natural causes, but there's something funny about that. When you look at the American presidents, George Washington, Thomas Jefferson, Theodore Roosevelt, and Abraham Lincoln, unless you really are nutty, you're going to believe that maybe erosion and natural forces could have produced that. Inference to the and that's called abduction. And so the idea of inference, to go where the evidence leads. So the best way of doing science is to go to the inference to the best explanation, but don't eliminate the possibility of design. And we already talked about the fact that there are design theories in many categories of science, forensics and cryptology, and a number of areas, archaeology and even SETI, the search record. They're looking for pattern. We know what that looks like. It's not unscientific to look at. So being open up to that possibility. But before I go on from there, I want to just go out from there for a moment and go back to another presentation I do. I do a thing on intelligent design, and I want to pull something out from that. Again, going back from there, from necessity, chance, or design. We're dealing with something that's contingent, it's complex, and it's specified. And it's intriguing to use some analogies that help people with this. And so one of them is, let me just get this thing here. Is that showing? Good, okay. So you look at this and you see these little stones here, and you see these little letters there. You get very suspicious, wouldn't you? You begin to see, if I have some Scrabble, a box of Scrabble, and is the, or those you can see from time to time in this. But when I see to be or not to be, that is the question. You're getting real suspicious, aren't you, that there's some impossibility that somebody's been tinkering with this. The odds here are this. There's the probability of getting this. You can look it up. I'll let you count the zeros, but it's pretty big. So the chances, we know there's an intuition, but the idea that the desperate measure that many take is that give me enough time, and the most improbable things can happen. That's often been the argument. Give me enough time. And actually, it turns out that time is not helpful for you, especially when you're dealing with kinetic systems. It actually goes against you, but that's another matter. But here, the improbability of chance is fascinating because George Bernard Shaw, give me 1 million monkeys over 1 million years, and they'll be able to write Shakespeare's Tempest. And there's been some ideas of this. Give me enough time, the most improbable things can become probable. So I decided to test this out a little bit. So you look at the Tempest, and let's suppose that we make it real simple. It's going to be this play that we're looking for, the target, is going to only have 4-letter words, nothing bigger. So it's a play consisting of 4-letter words. Then the probability of how do you get the sequence, and you don't have to worry about whether they're upper or lowercase or whether there's spaces or punctuation. So I'm being very generous with that. And we imagine we have 1 million monkeys, and they're typing 24/7 at 100 words per minute. By the way, experiments have been done with monkeys. It doesn't work very well. They defecate on the thing, and they hammer it with their fists, and they have a penchant for holding down the letter S. But they've never arrived at a cogent word. But I'm being very generous with these monkeys. So they're being fed bananas and so forth, and peanut butter, and they're working 24/7, and they never stop. And there's 1 million of them. So the reason why you have 1 million is if anyone gets the target we're looking at. So what you put those parameters together, and you get a reasonable probability. So the odds of getting that first 4-letter words would be it'd take about 12 seconds for it to do it. And that never happens, but I'm being very generous, as you can see. What about 2 4-letter words? You just need 2 in sequence. Again, don't worry about upper or lower case and so forth, but it'll take about 5 days to get it there. So we're beginning to look at the exponentials. Then we get 3 letters, about 100 years. The fun part is the next one. I want you to do an estimate or guess. What do you suppose how long will it take for them to get a 4th one? That is to say, 16 characters in sequence.
5 million.
5 million? Do I hear more? How much?
100 billion.
How did you know? Was that? Were you just guessing that?
Yes.
That's impressive. No one's guessed that high before. That's impressive. But you begin to realize that time is not your friend, and it turns out that when you begin to look at it, you can't get the first sentence, let alone the first act or the first scene. You can't get the first sentence. So you begin to realize the probabilities are not good. And that's really the thing I'm trying to focus on here. When you put it down to cases, it doesn't work very well at all for you. And we're going to be talking about DNA a little bit later when we talk about information theory, but we'll also talk about it in biogenesis. But it's the most densely packed, most elaborately detailed assembly of information in the known universe. So we're dealing not with randomness, but with information. But the information is independent of the chemistry, because and the double helix that the various bases, they're equal probability of having them, but the information is based upon the sequence of those bases, and each one of them has the same probability of getting there. So where does this information come from? It's a top-down thing. So I just wanted to give you that perspective here and go back out of that and go back into my science, faith, and reason and pick up where I left off. So I'm going to go to there. The designer, of course, was Gutzon Borglum, and we know about him, and he used, we could simple multiplication in a plumb line to transfer the measurements in a scale model into a studio in the mountain. I've been there, and I remember when I spoke at the governor's prayer breakfast there in Rapid City. I went there because South Dakota was there was only one state left now I have to see, and I've still not been to North Dakota, but all the other 49 I've been to. So if I get an invitation to Fargo, I'll take it, or Bismarck. No, don't. Okay. Well, I know the Coen brother movies on the Fargo, very funny stuff. But but I did that, and of course it was amusing. I said I'm going to see North by Northwest because it'd be fun to see, because it's featured there. And of course they didn't have anything like that on the top of the mountain and this airstrip and all that. But it's great fun to see that. But it was an extraordinary experience to see this achievement. Now I'm going to move into biogenesis. So I'm now moving. The first thing I talked about was a couple of weeks ago was the nature, the evidence for the universe's beginning, and then second feature was the fine-tuning of the cosmos. This is the third feature. It's called abiogenesis, really, but biology out of no biology. So you're dealing with how do you get the chemistry to work together, and it becomes very elegant indeed, because cell is exquisitely complex indeed. The standard model, as Michael Denton observed, is that undirected natural processes somehow turn lifeless chemicals into all the extraordinary complexity of living things. And he said that this chemical evolution model is no more or less than the great cosmogenic myth. And yet we're still clinging to him. The Uri Miller experiments and so forth, which was done over 70 years ago, and nothing's been done since then. They created a few amino acids, but nothing of the nature of even beginning of protein. So they keep on going with that, but it's the more and more evidence we have, the more possible it now seems to be seeing. Franklin M. Harold, in The Way of the Cell, describes a single-cell organism as a high-tech factory complete with artificial languages and their decoding systems, with memory banks for information storage and retrieval, elegant control systems regulating the automated assembly of parts and components, error, fail-safe, and proofreading devices utilized for quality control, assembly processes involving the principle of prefabrication and modular construction, because that's what we're looking at with this. The more you look at it, the more astonishing it becomes. And a capacity not equaled in any of our own most advanced machines, for it would be capable of replicating its entire structure within a matter of a few hours. The so-called simplest cell is more amazing than we could have ever imagined. And in fact, you take any so-called simple cell, there are no simple cells. Any cell is, if you blew it up to the size of Atlanta, it'd be about as complex with its fabrication systems, its factories, its transportation systems, bots, and all kinds of these pathways that it develops that are phenomenal, and the speed, working at the speed of a jet engine as it opens up the DNA and makes a copy of it in reverse, and then puts it back together again, and then sends it out into the cytoplasm for a machine to then turn that material, that transfer RNA, into this DNA, into a protein. So the body, we need this particular kind of, we have thousands of proteins. This type we need over here. And then it manufactures this system, and then it sends it over, and it builds this nano tube, and it creates a tube that goes across there, which it then takes apart when it's complete with that. And who's telling it where to go? Where's the brain in this thing? And who tells it how to unfold and uncoil the DNA in this exact place in this beginning to do that? The more we learn about it, the more astonishing and almost frighteningly complex it's becoming. It's not simple at all. And this is the whole idea, because you're looking at something that it would be, it was previously thought by Darwin and his followers in the 19th century that the body was elegant, yes, but that the cells are fairly simple. By analogy, they thought the cells were like Lego blocks. They called it just protoplasm, a basic blob, and so forth. But it turns out that each so-called Lego is the complexity of a miniature body. And the more we learn about the cell, the more extraordinary it becomes. So even atheists, and Thomas Nagel, interesting, because he didn't curry a lot of favor with his fellow atheists when he wrote this book about the impossibility of Darwinian evolution. It's kind of an interesting thing. But he said, for a long time, I've been skeptical of the claims of traditional evolutional theory to be the whole story about the history of life. He goes on to say that it potentially can be scientific to argue that the data of DNA and life points to an intelligent designer. But he goes on to say, even if science cannot tell you the identity of the designer or what is going on in the designer's mind. Now, it's not to say he buys that, but the fact is that he argues that the impossibility of this without some kind of agency. There's got to be some kind of agency, but he doesn't go far enough as I'd like them to see and let go of the atheism, but I'm pretty impressed. So you have this idea, what would it take to get one living cell? And that's what we're going to ask about very quickly here in our time. You can't appeal to neo-Darwinian mutation and natural selection because that implies living systems. So we're not even talking about evolution. You see, you can't have evolution if it's not alive. So I'm bypassing the whole evolution business and looking at how do you get life, and what is life? And when the cell dies, what died? What was different? And so it's very mysterious stuff. So the supposition that the cell could evolve was not a problem for Darwin because he thought of it just as so much protoplasm. But now we've peered inside that box. As a result, we are now using things that show, using X-ray crystallography and nuclear magnetic resonance, we've actually been able to delve deep into find out that the cell is exquisitely elegant. It's more elegant than a major city. Human engineering and technology has never been able to match this, and so we can predict that many new complex, elegant features will be discovered. But this is an exciting time to live, and so we're looking at Darwin's black box. It's written by what would it take to get a living cell? So Darwin's black box. I remember reading this when it first came out by molecular biologist Michael Behe. And Behe argues that the cell is black box because we've peered inside that box now. It turns out that these methods have shown that it's exquisitely elegant, more complex, as I said, than a major city. When you look at it, these are just some simulations of what it looks like. Human engineering and technology has never been able to design anything remotely like the complexity of a single cell. We can predict that many new complex and elegant features will be discovered. The more you see, the more amazing, shocking almost it becomes. So this is an exciting time to live. In the last 4 or 5 decades, we've seen a plethora of new things that we could never have even imagined. So I'll just say a few words about just a handful of problems that we can just deal with. One of them is the possibility of creating and synthesizing a simple protein through undirected natural processes. A protein consists of hundreds of amino acids, and there are 20 types of amino acids in our body, and it's significant that it requires a gradual buildup of these polypeptide bonds, and each one becomes less probable than the one before. So there has to be something that holds them together and sustains them. The rate of dissolution will actually exceed the rate of buildup. But something's got to make them work and build them up. And to get a polypeptide chain of even 10 amino acids is no simple task. But there are hundreds of these amino acids in these cells. And so we're dealing with a gradual buildup of polypeptide bonds, a precisely ordered sequence. Then to make matters worse, so the probability of building that is so low, and if you looked at that, but it gets even worse, because it turns out that even though if you had the correct sequence of the right amino acids, you need to have each of the 20 types, they have to be left-handed. And it turns out in nature, there's an equal probability of being right or left-handed, which is an interesting thing. But all of your DNA, all your amino acids in your body in all living systems are left-handed. And no one understands how that works in a very clear way. But so you have these left and right-handed, but the difference between them is the mirror symmetry between these three-dimensional structures, which is similar to that of your right and your left hands. And so it's so we see this astonishing. The proteins in plants and animals on our planet, from the simplest organisms to the most complex, are all made up of these left-handed amino acids. And if even a single right-handed amino acid got attached to the structure of a protein, it would be rendered useless for life. So this is an astonishing thing. So I'm being conservative with a protein of 400 amino acids. Some of them are thousands of the things. But it would be like tossing a fair coin 400 times and getting heads every time. Would you get suspicious after a while? After a while, you begin to wonder, maybe it's more than the coin's been fixed. Maybe it's got a head on both sides, because otherwise it's not going to happen. And then these numerous proteins combine thousands of amino acids. So the probabilities are not looking good there as well. So how did you even get that? So how do you get the chains? And then how do you get them all being left-handed? And what makes it also more complex is that it'd be three-dimensional topology. So yet a different dimension of information, because you have these primary, secondary, tertiary, and quaternary systems of protein folding. We can't fold them at all. We can't do this in the laboratory. We can't make these things. We can't replicate them. We can only imitate them. But the idea they fold into these things, and the idea is that you have to have all these complex carbohydrates and so forth in order for you to actually have this work in the cell wall, and you have to have the lipids to form a membrane. There can be no proteins without DNA and RNA, but there can be no DNA and RNA without proteins. So it's an important, issue, which came first. And so you have to have both of them. But each structure becomes more elegant. So there's a primary, then it folds into a secondary, then a tertiary, and a quaternary. And the three-dimensional topography actually adds information to the protein itself. And thus, it's not surprising. So people have been plumped for an RNA world, hoping in desperation maybe RNA will work instead of getting a bypass around the protein. It doesn't work. It's a desperate attempt to avoid what's painfully obvious. There's something going on here that you cannot account for. Because of these problems, some writers have appealed to what they call directed panspermia. A desperate measure, because they're admitting that it couldn't evolve on Earth, so it must have been seeded from outer space. Sometimes scientists don't make the best philosophers, and so sometimes that happens. The obvious question is, where did that come from? Just push it back one level. It had to be synthesized. So if you're appealing to something without a designing agency, you have a real problem. I love rock cairns because they fascinate me. I'm just taking something very simple. You've all seen rock cairns. You go to maybe a pond, a river, or a stream, and somebody who has a little extra time on their hands builds one of these things here. And if you look at that, what would you conclude? It's possible that it was formed by natural processes, right? Possible. I wouldn't put my money on it. It's like, again, the turtle on the fence post. Remember we talked about that? What are your probabilities of getting a turtle on the fence post? Might be pretty good that it's not to guess that a gust of wind popped it up there and propped it up and made it happen. Maybe somebody put it there. Same with here. And these are not complex things. These are very simple structures. But as soon as you see it, what does it tell you? There's an agency involved. And so we're talking about something child's play compared to the simplest structures in the cell. So, and some people have more time, too much time on their hands. That's an elaborate cairn as well. In fact, so it's amazing stuff. So, in fact, I have a little thing I can't resist. Rock cairns. Yeah, I have my own separate presentation. So here's what I showed you before. So are these. I mean, but some of these people really have too much time on their hands. I don't know, but it's pretty impressive, these little things you build. But you see this, and what do you immediately conclude? But it's something very child's play compared to these things. But there's my turtle on the fence post that I told you about before. If you look at this, it's kind of a fun thing to see that, because the butterflies what's interesting is you see the structure, it looks like a heart. Oh, somebody made that. But people then presume that the butterflies themselves are random, that they came they evolved through natural selection and mutation, which is astonishing to me. Or something like this, if you see something like this, wouldn't you get suspicious? Once again, it could happen. Where would you put your bets on it? So again, something this simple is suggestive of something far more elegant, more complex, more rich, more amazing than you could have ever dreamed. Pontus Jansson, he creates these things. There are videos of him making these things, and he does it without any glue or anything like that. It's just amazing. The guy's he's a genius at making them. Look at this. He knows how to balance these right. And you see him actually build them in these videos, and they last, I don't know how long, but he balances these things. And again, you look, I like to collect crazy things but what a mind, what an ability he's got. But immediately you see this, and what do you know? You know there's a mind behind it. That's my point. You see that, and it's an evidence of a creative mind. That's a creative one right there. Just amazing, this guy's. Again, seems to be all he does. Because he's built a lot of these, hundreds and hundreds of these things. I'll stop there. But you get the idea that you're dealing with something that's so rich and complex. So that's the nature of the biogenesis. Again, just the simplistic overview, but it just gives you setting up the problem. And the more you look into it, the more amazing and more elegant it becomes. Before I go further, I want to see if there are any questions that we have. Because, yes, go and use that little stand and turn on the mic when you get it. Is this helpful for you? I don't know if it's, yeah. Is it interesting? Okay. Okay.
Okay, Ken. My question is, with all that you've told us about the RNA and so forth, explain what gain of function is that we've heard so much about in the context of your talk.
With what?
Gain of function.
Oh, gain of function?
Yes, and what that can only happen because it was done in a lab, that there's nothing that's natural about it, as I understand it.
Yes, in fact, when these Urey Miller experiments and others that have tried to replicate these things, and they get some tar and they get a little bit of DNA and so forth, but it's nothing that's impressive that's going to be dealing with anything, the beginning of a protein or anything like that. But what it does show is that even there they cheat, because they actually pull these things out, because they have to have the reagents and purify the material itself. There's a lot of conditions. And when they're trying to replicate something and imitate and take the materials there and reconstruct it, they're not doing it, they're not creating life, but they're imitating materials and then modifying it. But what that shows is intelligent agency that's involved in even creating the conditions for that developmental outcome. So the very thing itself is showing that there's the investigator interference, that there's an additional component of intelligence that's necessary even to set it up. But mutations in natural selection, left to themselves, doesn't produce information. It produces chaos and randomness. Yes. You have their mic on? There's a button on?
Well, yeah.
All right. Make sure it's on.
It goes sideways, but
Set that. A sideways button?
wall basket.
Oh, here we go. I heard it pop.
I hear something. Yes, Ken, how do you explain like the Neanderthals, Homo sapiens, and how
Yeah, this is a totally different discussion, but it turns out that there aren't really the transitional fossils that you need to have between the ape and the man. That you have, I won't go into the details here, but most, in fact, if you use many of these programs now to check on your DNA, some of us have a certain percentage of Neanderthal in us, because it was a Homo sapiens. It was not deficient. In fact, it had a larger cranial capacity than we do, and you may have run into a few, but you have a little bit in your system already. But but many of these things were hoaxes as well. Piltdown Man and so for Nebraska Man and a lot of these things. But the Cro-Magnon, it's Homo sapiens and so forth. You don't see in one or the other. You don't have the transition that they have. So you have this little movement from one to the other. It doesn't apply in nature at all. It's not at all. It's been and yet they still cling to that, even though those things have been discredited. Yeah, but that's a separate matter. That's another subset. Well, we could begin the information theory. Let's do that. So the fourth feature then, after we talked first about the evidence of the universe at the beginning, and again, I'm not appealing to Scripture. I'm appealing simply to science and inference to the best explanation. But I did claim that the theistic environment created the context in which we would have the appearance for the first time in human history of empirically based science. It wasn't done in China, it wasn't done in Egypt, it wasn't done in the East and India, because they had technologies, the Greeks did and so forth, but they didn't have empirically based science. That was based upon the idea that the universe is ordered, and that it's ordered because of an ordering mind, the Logos, and that we who bear the image of the Logos have a capacity to correspond to that and understand it. So it implies that it's not only a universe, not a chaos, but also that we who bear the image of the Maker can also understand, and He's made it communicate. So it creates the conditions for that. That's why I tried to show you the original, many of the earliest scientists regarded this as part of their worship. In fact, when you look at Newton, Kepler, and Galileo, and Mendel, and all these others, and it's astonishing to see that. So we're going now to the fourth one, the fourth feature, information theory. Our bodies are rich in information, and there can be no sudden infusion of complex information through undirected natural processes. And that's very important to understanding. And so there are beautiful natural patterns, and I want you to notice that, but their patterns aren't the same as what I'm talking about. So there are beautiful natural patterns in snowflakes and in crystals. And I have a whole booklet that I've done on snowflakes because they're so marvelous. Crystals and also sand dunes. There's these beautiful, complex natural patterns. You see them also in hurricanes and tornadoes and stalagmites and stalactites and so forth. And so nature abounds in fractal systems. You see them in trees and so forth. And the geometry of trees is astonishing because they're fractal, and yet there's a second geometry that they correspond to that actually corresponds to our own geometries because they create these complex, ordered domes or different kinds of plant structures, but also fractals, the Mandelbrot and Julia sets related to chaos theory, and they're mathematical descriptions of really elegant patterns that go on forever. But pattern is not the same as design, and that's what I want you to show. Even though you might have beautiful patterns, it's not the same as this of design. So when I, for example, look at, you don't have the kind of information that we're dealing with. Unlike a fractal, you're dealing with, like, say, music, or if you take maps of instruction, maps or instructions, now you have something very different. You have something, human language is this way, computer language, and of course DNA. So there's a difference between patterns and something that actually has design agency. And so that's what we're looking at here. It's specified complexity, it's been described as. And your DNA, we're living in an extraordinary time because it's more toward elegance and supreme organizations that we can see it. Turns out that the evidence is moving us more and more toward elegance and sublime organization. As we can see this, it's the most sophisticated communication protocol in existence. So there are letters and words and sentences and chapters. So DNA is a language, and it encodes the information necessary for life. And so we have these letters for this alphabet here. So you have these four components here where you have the instructions here. So the thymine, the adenine, the guanine, and the cytosine. It's those four letters, but they combine together, and they correspond to letters. And then these three letter codons correspond to words effectively, and that it actually is corresponding to a DNA, or rather to an amino acid that it's going to code. And so then the genes they come together and form genes, and that would be the equivalent of a sentence. You have the alphabet, you have the words, you have the sentence. And then you would have, from there, the chromosomes would be equivalent like to a chapter in a book. You see the idea? And then finally, the book itself, the genome, is the book. So you have this correspondence here. When we have to ask this question of this complexity and wealth and of richness, where does this information come from? So one single cell can carry more information, more data, than an entire set of encyclopedias, for example. And we haven't even mentioned an entirely different form of information that transcends the genome. But we're looking at something that involves these three components. I'll go back to this for just a moment here. So you have to have these components here. But you have it symbolically represents something that it needs to have a transmitter and a listener, a receiver. It has to have the elements of language. So you have to have some system that transmits something that receives it, and you have the language of commonality. But even there, it's not enough, because it's even more elegant than that. Because information has to have an alphabet, it has to have syntax, it has to have meaning, and it has to have intent. So, for example, I can say, he didn't steal that car. He didn't steal that car. It's the same sentence, but it has different meaning because it's top down. It's not bottom up. And that's the important thing for us to see there. The same sentence can mean something entirely different according to the intended meaning, which is brings us to the next level, which is called intentionality. And so you're dealing now with, suppose you have a green light, and the lower cannot account for the higher. What does that mean? It means you can get moving, or it could mean that you have a go-ahead for a project, or you're dealing with the intentionality. And the lower can't comprehend the higher, but the higher can always account for the lower, but reductionism will not account for what transcends it. As Norbert Wiener put it, he said, information is information, neither matter nor energy. And by this he means any materialism that fails to take account of this will not survive one day. So we're dealing with something that's pretty fundamental. What do we mean by information? I claim that it transcends matter and energy. So right now we're having this conversation, and it's being recorded. And then we could take this recording here in in any number of ways, and you could send it to someone. You can read it, and then you could print it out. You can see it on the screen. So the same information would be then, you could see it, for example, electronically through energy, or you could see it on a physical page. You see it can be printed out, but this is the same information. Information transcends the nature of the thing that delivers it. And that's what's fascinating to me. So you have this issue of take for example, a DVD. You have a DVD, and one has a film on it, and the other one doesn't have a movie on it. Does it weigh any different? Is there any? It's just the way it's coded, you see. But information, what's fascinating is the information transcends the matter and energy. It can be conveyed, the same information can be conveyed by physical material, by matter, or by audible, or visible. So it can be energy. You see the concept there? But it transcends it. It's the third ultimate. And so I claim that it's almost like in the beginning was the Logos, the mind of the maker. And so that information is the third ultimate as I see it. It's pretty impressive stuff when you look at this, because where does information come from? And that's the question. So the atheist riddle is, show me a message that doesn't come from a mind, and a coherent, cogent message that doesn't, and there aren't any. So it's ultimately a derivative. So when you look at randommutation.com, it's interesting because you go back to this website. The quick brown fox jumped over the lazy dog, and watch the fun as it mutates. And you'll discover the sentence becomes more chaotic and becomes more and more incomprehensible, because mutations aren't beneficial. They are deleterious. They're chaotic. They break things down. This is why we're devolving. We're not evolving. We are and mutations are being carried on from generation to generation, and the genetic load is getting worse and worse with every generation. We're not as bright, and our capacity is not as great as our ancestors in the past, in the distant past, but that's another story. We make up for it with our technology, though, that amplifies that, but it's another matter. So what I'm suggesting here is that the lower cannot account for the higher. Your body consists of your cells, and has your tissues, and your organs, and also systems. But all of these things synergistically fit together in ways which the lower cannot account for the higher. And so you have this whole idea of promissory materialism. And it's interesting because I've talked about this with groups of atheists and so forth. And I remember one conversation with a person who says, I know it doesn't look good now, but we'll find it. How did that happen? I must have hit a button that I just didn't intend to hit here. Promissory materialism, go back to where I was. So by promissory materialism, I'm saying eventually they'll find it. And it wouldn't put my information, because it's faith without evidence is what we're talking about here, you see. And so as I said before, the first two laws of thermodynamics show that the universe cannot be eternal. But it's an exponential decay curve that shows the diminishment of useful energy as time goes by, which if you press it into the past, it reaches a point where there was all useful energy, but you can't have more useful energy than total energy, so you had to have a beginning point. And then there's another questions there. But I'm just suggesting here that the exotic mathematical theories that have no empirical warrant and they hold to them, and they violate the most fundamental laws of physics. So again, desperate measure of faith to avoid the evidence that's right in front of them. So then there are other features of the world as well. Human consciousness, rationality, moral values and obligations. These are high functions. These are high things that need to be taken into account and are usually not. When our resonance and response to beauty would be a meaningless thing in a chaotic cosmos. Human dignity, value, and purpose is usually at least assumed. The idea of human rights and universal religious experience, all of these have features that point beyond themselves as a top-down world rather than a bottom-up world, if that makes sense to you. Now, I'm just about out of time, and I didn't quite finish this, but we can do this another time. I can finish up with the implications later on and tie it together for you and give you some extra. Time for maybe one question or this making sense to you? I'm just trying to give you a big picture is all I'm trying to do. I don't mean for you to know the whole, but I want to show you that when it comes to evidence, the evidence is on the side of a theistic vision, of a top-down vision, of a mind, and that we are people who are agents who are not the product of the impersonal blessed time and chance, and all these other features of the world that we presume and know make that very clear. So it's the default mechanism until the so-called Enlightenment was a theistic consensus, and we achieved the greatest levels of art and music and science and literature and education and all kinds of the things. It was an astonishment efflorescence for about 1,000 years, but since that time, there's been a movement away from that, and it's transitioned from a theistic vision to a naturalistic or physicalistic, materialistic vision. But it's interesting that it did that by way of deism, because it would have been too much of cognitive dissonance to go from theism to physicalism. So that deism, the clockwork universe, God wound up the universe. He hasn't been seen since. You see, the transitional move. But ultimately now the default mechanism is the assumption of an atheistic or a non-theistic vision rather than a theistic vision. But this is the interesting thing, and I'll stop with this. As I mentioned this before, Pascal, in his wonderful Pensées, one of the things he said is that God has apportioned the evidence in such a way that there's enough evidence to satisfy the mind of a person who chooses the way of faith in God, but there's enough ambiguity to allow the atheist to rationalize his disbelief, because he's not going to force it upon us. Here's the interesting thing. What happens, though, when the culture moves away from a consensus of theism to a consensus of a naturalism? Guess what God does? He bumps up the ante of evidence. And it was in the so-called Enlightenment in that 17th century that the telescope and the microscope were invented. And suddenly he revealed, okay, now you're going to be moving away from me, but let me show you some evidence you didn't know about. You didn't know there was a microscopic world. I'm going to show it to you. You didn't know there was a macroscopic world that had things that you couldn't even believe that are out there. And what's happening is, and especially in the last few decades, as time has moved more and more, it's only increasing. So the evidence, God's using science and technology as a vehicle of displaying his glory in the world, and it's becoming more and more of a rebellion against his purposes and pushing back against what's painfully obvious. And so it reminds me really of the Romans 1 process, and I'll stop with this, that the spiritual, it really always starts with the spiritual. Then it involves intellectual distortion, and then finally the moral decadence. And so it moves in that direction. So it's not the question of, even though they knew God, they didn't honor him as God or give thanks, but they became foolish in their speculations, and their foolish heart was darkened. Professing to be wise, they became fools, and exchanged the glory of the incorruptible God for an image in the form of corruptible man, birds, and four-footed animals and crawling creatures. In other words, they dumbed themselves down because of their choice to refuse to believe it. So the atheist, the person who says there is no God, is not intellectually deficient. There's a refusal, a volitional issue that comes down. But as the evidence comes on more and more strongly, it becomes more and more a pushback, a rebellion, a cultural thing. But there are some amazing forces that are at work in our time. So we'll stop there. Entropy in action, yeah.